In section 4.6, which is titled the Algebra of Functions, we're going to add, subtract, multiply, and divide functions. Let's start with adding functions. If you've got f of x is equal to x cubed plus 5x squared minus 6, and g of x is equal to negative 2x squared plus 3x cubed, the function notation would be given to you as f plus g of x, f plus g in parentheses, and then the x in parentheses does not mean multiply. Recall that that is function notation. But what that means is we're going to take the f of x function and add it to the g of x function. So with adding, it's really a matter of combining like terms, something you've learned a while back. We would take everything that has an x cubed term. We would take x cubed plus 3x cubed and add those because those are like terms. And we would take the 5x squared and subtract 2x squared because those both have an x squared term. And then the negative 6 doesn't have anything to combine with, but it's still part of our solution. So we're going to add x cubed plus 3x cubed and get 4x cubed. We're going to take the 5x squared and subtract the 2x squared and get 3x squared. And then bring down the minus 6. And that is your solution. Make sure when you write your answer, and I'll remind you of this in the next example as well, make sure you write your answer with the highest exponent first, always, followed by the next lower exponent, which is a 2, and then on down as your exponents decrease. Now let's do one where we subtract one function from another. F of x is equal to 2x cubed plus 7x to the fourth minus 2x squared, and g of x is equal to 4x cubed minus 6x to the fourth plus 3. The first thing to notice is that these expressions are not written from highest exponent to lowest exponent, but you're going to be careful as you do this problem to put your answer that way. When we're subtracting one function from another, we have to be careful that we subtract the entire function, not just part of the function. So when I wrote the problem to begin with, I showed g of x, and then I showed subtracting f of x. F of x is a polynomial, so I need to be sure to subtract each one of those terms. In the next step, where I removed the parentheses, I simply rewrote g of x, and this time I'm distributing the subtraction symbol, or a minus 1, all the way through the second function. So I'm subtracting 2x cubed, I'm subtracting 7x to the fourth, and I'm adding 2x squared because subtracting a negative is a positive. Now I just go through and combine like terms. I'm going to start with the terms that have the highest exponent. So I have negative 6x to the fourth minus 7x to the fourth. I'll combine those in my next step. I have plus 4x cubed minus 2x cubed. And I have a plus 2x squared, nothing to combine that with, and a plus 3. Now let's write the final answer by combining all terms that have the same exponent. Negative 6x to the fourth minus 7x to the fourth is negative 13x to the fourth. Plus 4x cubed minus 2x cubed would be plus 2x cubed. Plus 2x squared plus 3. When multiplying functions, we're going to use the distributive property, and it may be a very simple problem where you have a monomial multiplied times a binomial or trinomial. It may be two binomials multiplied together where you would use FOIL. All of those use the distributive property. I'm going to show you one where I have a binomial, f of x is equal to 4p plus 5, multiplied by a trinomial, h of x is equal to 8p squared plus 5p minus 1. I'm going to show you two different ways to do this problem. The first one, I'm going to just use my distributive property, and then on the next one I'll show you how to do it using a box or a rectangle. Using the distributive property means I'm going to multiply the 4p times 8p squared, then times 5p, and then times negative 1. 4p times 8p squared is 32p cubed. 4p times 5p is 20p squared. 4p times negative 1 is negative 4p. The next thing I'm going to do is use the distributive property and multiply 5 times 8p squared, then 5 times 5p, and then 5 times negative 1. Whenever possible, I'm going to put like terms above or below each other. So 5 times 8p squared is 40p squared. I'm putting it directly below the 20p squared. 5 times 5p is 25p. I'm putting that directly below the negative 4p. And then 5 times negative 1 is negative 5. Now I'm going to treat this like I am adding two functions, and it'll give me my final answer, and I'm making sure I have it in the order of highest exponent to lowest exponent. The previous problem can also be worked using a rectangle. I take each polynomial and I put them outside the rectangle, and then as I multiply, I'm going to put the products inside the boxes, and then it just helps students remember what they've multiplied together and what they haven't. You're going to still get 32p cubed, 40p squared, 20p squared, 25p, negative 4p, and negative 5. The difference here is that you're gonna choose your like terms. Combining like terms is still what you do, and then your answer is still going to be written, as always, in highest exponent order to lowest exponent order. Just a different look, but you arrive at the answer that you got previously when you use the distributive property. When dividing functions, the key to that is thinking about whether any part of that quotient can be factored or simplified. You want to always factor if possible and simplify. Sometimes no simplifying can be done, and your quotient is just one function stacked on top of the other function. In this particular case, we've got f of x is equal to x squared minus 5x plus 6, and g of x is equal to x minus 3. The function division, f over g of x, means f of x divided by g of x. So that would be x squared minus 5x plus 6 divided by x minus 3. Well, the top can be factored into x minus 3 and x minus 2. And then the x minus 3 can be canceled with the x minus 3, because remembering your canceling rules, you can cancel a binomial that matches another binomial exactly, and your answer would be x minus 2. So when dividing functions, always check to see if anything can be done to simplify or cancel parts of the function to simplify it down to its basic form.